Okay, so now we have Alina Arseniev from UCLA, who is going to tell us about cultural dimensions in word embeddings.
All right, thank you. Okay, so I'm going to start out with this interesting problem that computer scientists noticed a few years ago. It's something called machine learning bias, and we can see it really concretely in the case of Google Translate. So in English, we have he and she as our pronouns, and if we take other languages like Turkish, we don't have he and she, we just have something like it. That's that O you see up there. So if we take the sentence in English, she is muscular, and we translate it to Turkish, we now just have it is muscular, so we've lost that information. But now if we want to go back and take that same thing and go back to English, now it has to suddenly decide, are we talking about a he or a she? In the case of muscular, it makes this inference. We're talking about a he. And we can do this for a bunch of different examples. In the case of fat, it's a she. In the case of nurse, it's a she. In the case of doctor, it's a he. Programmer is a he. It starts fitting all these stereotypes, which is really interesting. For computer scientists, they kind of were horrified. They're like, oh crap, you know? That means that all these algorithms that we're training and using all these underlying models of language are learning things like gender in very biased, stereotypical ways. For a social scientist, this is interesting, but it's not that surprising. Meanings of gender, just like other meanings of culture, are everywhere in our language. So if you're learning language, you're also learning culture. So there's been these two strands of research trying to understand what's going on with these language models. One of this is called machine learning bias. And that's where we kind of look at like, what's the gender, the meaning of gender that's being learned? How can we extract it? How can we play with it? How can we actually remove that bias? That comes up with a whole other set of issues I won't talk about today. But then there's this parallel strand of research in social science and culture that I'm part of, where we think of this as an exciting opportunity to learn about our culture, since it's in our language. And so we can kind of probe all these word embedding and other new language models to learn about ourselves. So we can extend some of those methods that computer scientists have developed to examine not only gender, but also things like wealth and morality and a bunch of other dimensions that I'll talk about today. So the main points I want to get across is that we have lots of evidence at this point that these word embeddings and in general, these models of language are learning culture, not just the meaning of specific words. And we have at this point a number of methods from computer science to actually extract those meanings, to extract what is the dimension of gender that we learn, and how can we then do new things like take a word like nurse and look at how it's gendered. At the same time, these methods are still pretty early, and even though they're being deployed in all these ways, we don't actually know how they work, and I'll explain some of them today, but we don't know why they work. We don't have good validation methods yet. So I think it's important to maintain this kind of healthy skepticism that I'll talk about throughout this talk. And I'll show you this exactly how we can extract some of these cultural dimensions in word embedding models like gender. And I'll give you a very specific case example from some research I've done on news reporting on the obesity epidemic and how obesity is framed with respect to morality, social class, health, and gender. At this point, I think we've had enough reviews of Word2 Vec, but I still think it's important, in case anybody hasn't been here for the past 2 days, to just remind you, Word2 Vec at its core is just a way to turn words into numbers. And ideally, those numbers mean something. So we can think of this in the case of your king and man. They share this dimension, these ideas of masculinity. So in a good model, these two words would have similar quantitative representations. That means that their representation along the x-axis, the z-axis, and the y-axis will all be similar. We can think of this visually, like this x, y, z. We can also think of it as just a list of numbers and the loading on each of those dimensions. So these are two equivalent ways to think about a word embedding, aka just a word vector. And we can think about also the closeness in space. We can measure that based on how similar they are across all these dimensions, and it's something called cosine similarity. And that's something that I'll keep referring back to throughout the talk. It ranges from 0 to 1 in this case, where 0 to words that are totally different. 1 is going to be when they're exactly the same word. And just so you believe me, if you haven't seen some of these results before, if you take a word like obesity, train on a Word2 Vec model on a bunch of news data, and we look at what the most similar words are, you can see that the most similar words kind of match our intuition. It's things like childhood obesity, obesity epidemic, and they have pretty high cosine similarities. So it's not just spurting out random words like king. King is not in there, right? That is not the word that is closest to obesity. So then we get to the more exciting stuff. Once we just learned the meaning of words, how do we get to learn the meaning of higher order constructs like gender? Gender is not just a word, it's this construct that ranges from femininity to masculinity with something in the middle, maybe gender neutrality. That's a different talk. And so how do we actually extract that dimension of meaning? Well, it starts with this kind of basic assumption that we can take a word like man and woman, and a lot of the meanings of man and woman are the same, both about adults, both humans, both animate, singular. All these things are the same except for that key difference of gender. So then if we subtract man and woman, what we're left with is we are kind of washing out all those differences that are the same, and we're left with this just gendered component. And so that's what I've kind of shown you here. And of course, if we just do this with woman and man, word vectors are messy. There's a lot of messiness. So this is giving us kind of an approximation of our gender direction. So what we can do then is once we have this gender dimension that ranges from hyper-masculine at one end to hyper-feminine at the other end, we can take some new word and look at the cosine similarity to look at how that word is gendered, so it's on the masculine end or the feminine end, and then also how masculine and how feminine. So it's kind of cool because it's telling us not only this binary thing, but this continuous thing, right? And we can look at both of those. So basically what we're doing again is just looking at the cosine similarity between our gender direction that we've found and our new words, such as if we want to go back and test where woman is lying on that dimension. And we're expecting that a word that is feminine is going to lie on one end in all the positive ranges, and the masculine word is going to lie on all the negative ranges. And we can generalize this method to all kinds of things. We can generalize it to morality, social class. There's limits to how far we can generalize that, and I'm happy to talk about that as well, because that's something I'm really curious about. So we can do it a little bit more robustly. As I mentioned, woman and man, that's a pretty big assumption that they're exactly the same word except for gender. There's all kinds of noise going on. A way to do this a little bit more robustly would be to do things like take a bunch of feminine words, average them, and then we can take a bunch of masculine words and average them and subtract the two. So we get a little bit better measure. As far as how to choose those words, there's a number of different procedures. I think that Jaren's talk yesterday goes really nicely into thinking about how do we extract an idea of femininity that's both coherent and very distinct. And there's a number of other variants of how to do this as well. But this is kind of the core idea. OK. So then the next question is, how do we validate this? I've made all these assumptions, I've shown you some math, but does that actually work out? Sometimes it does. In the case of gender, it does pretty well. So what we can do then is look at, take a bunch of new words that I did not use to create that dimension and look at how they're classified. So is the cosine similarity on the negative side or is it on the positive side? Is the cosine similarity masculine or feminine? How masculine and how feminine? We can compare it to what our expectations of those words are. In that top case, housewife, we have this expectation that Word2 Vec should probably pick it up as feminine. And as you can see, it's on this positive side, the cosine similarity with the gender dimension, meaning that Word2 Vec has matched our intuition that it actually is feminine. And this works in a lot of different cases. And we can do it, what you're seeing here is a distribution across 25 different Word2 Vec models that are kind of subsampled on different slices of data. So you can see how sensitive this is to if we took just a snippet of our whole data and did this whole procedure on. So it's pretty accurate. 27 out of these test words are correctly classified, at least. And again, I kind of want to keep honing down on this idea that we can think of this as something binary or continuous. And those are two very different things. So if we keep thinking of this in the binary way and how to validate this in the binary way, we can do this with a bunch of different dimensions. Oftentimes what we get is that, at least in what I've seen when I've tried different dimensions, is it's not that hard to get this high classification accuracy on new words. It starts breaking down once you get into some concepts, but at least in the case of these four, with gender, morality, health, and social class, it's a pretty straightforward task to do. That doesn't mean it's a good validation, or that means that it's validated, that this whole method is valid, but I think this does give some evidence that there's something there. At the same time, I think this is almost to be honest, this is a very easy classification task. So it's at the bare minimum, it should be able to do this. But we can start looking at how this breaks down eventually. So then we can also think of this as something continuous. And often this is the more standard way to evaluate how well, if we extract a dimension like gender, how well is that extraction. If you read papers with using this method, this is often what they're talking about, is looking at it in a continuous format. So what you're looking at here on the y-axis is the morality according to human raters of a bunch of different stigmatized conditions like bipolar, obesity, all kinds of things. And then we're looking at how that relates to morality. If we did that whole procedure, we found a moral dimension, and we project these stigmatized conditions onto that moralized dimension, and then look at if it's more immoral or moral. And basically what you're seeing is that stigmatized conditions that are more immoral according to human ratings also tend to be more immoral according to our methods with Word2 Vec. At the same time, this is not a one-to-one correlation. The correlation is around like 0.5, 0.48, so I explained some of it, but it's hard to know. Like, does this mean that like our method is invalid? Does this mean our whole validation is not the right way to do it? And this is something that I've been struggling with in my work, because I also don't know that this is even a good validation metric, even though this is state of the art. The problem is that when we're saying that morality in Word2 Vec, this is taking from news discourse often, or Wikipedia news, or some large-scale text. And so then we're making this assumption that we should see this one-to-one relationship between what is in our environment and the types of representations and types of meanings of morality in our environment, and then what's actually in people's heads. What do they actually think of when they see this word like cocaine or paroled or all these different things? And there isn't necessarily this one-to-one relationship between what people think and what's in our environment. We don't absorb it perfectly. So, but this is kind of like what is the way to do it at this point. So now I'll show you this in a little more concrete case, the case of obesity reporting. So I took a bunch of Word2 Vec models trained on news reporting on obesity discourse from 1980 to 2016. And I have a bunch of qualitative literature that has this very strong suggestion that obesity is framed as immoral, as low class, as something that's talked about more in context of women than men, and as something that connotes illness. So what we can do is take these 4 dimensions, morality, social class, health, and gender, and then test how these dimensions make up the meaning of a bunch of lexicon that's in this discursive field. For example, the words like obese and overweight. Are they classified as masculine or feminine, and how masculine and how feminine? What we find is that a lot of things end up matching these intuitions. So for example, obese and obesity are feminized, just as qualitative literature would have predicted. But what's cool is we can start going and diving in a little bit more. We can test specific words. We can do things like notice that it's not just obese and obesity. It's actually all talk about body weight, weight loss, and dieting that ends up being discussed in context of women. In the case of morality, again, obesity and obese are immoral. But it's not just that obesity and obese are immoral. We can start noticing there's things like, in general, health and beauty are moralized, while illness in general is immoral. We can compare specific words. Like, you'll notice that the word thin and slender is actually very different. They come out very different across all of these different dimensions. Thin is always a little bit more negative than slender. And that's something I've been thinking a lot about, and like asking people, like, what do you think of thin versus slender? You know, once you find this, you have to kind of go and like think a little bit more carefully. Yeah.
Point out where thin and slender
Oh, right.
read the words.
Yeah, that's a little bit small. So thin and slender is the 3rd and 4th word up there. So slender is much more moralized than thin. Slender is also more, as we'll see, it's more high class than thin. It's more healthy than thin. Yeah. Oh, yeah, I'm not very good with pointers. I don't want to get in someone's eye, so. So again, we can see obesity and obese are on the unhealthy side, even though the actual links between health and obesity are, according to science, still a little bit fuzzy. But as far as in meaning making, it's definitely on the unhealthy side. Again, similar things with class. You know, we can go through and start validating all this stuff, and we can also use it to learn new things, such as this difference between thin and slender. Again, the 3rd and 4th word are slender there, and you can see that thin and slender are not the same word, which is something that I hadn't thought about before. Yeah. So then there's the question of why can we actually extract culture in this way? It seems too easy. It seems too simple. So something that Kozlowski, who's used these methods, kind of brought up is that a key structure of meaning is a binary opposition. This is something that sociologists thought about a lot in the 50s and then kind of forgot about. Turns out that a lot of these constructs that we're measuring are binary oppositions. And a binary opposition is when we have 2 concepts that are defined relationally. They're defined by each other. So for example, our ideas of masculinity is defined by the contrast with femininity. And a lot of these things that we've tried measuring are taking on that same form. So that's pretty interesting. And we know that a lot of meaning probably takes on this form from all that old theoretical work. At the same time, we also know that not all meaning takes that form. And so then this kind of brings up the question, like, to what extent, like, does meaning actually fit this form, and what about all the ones that don't? Like, how do we measure those? And how do we know if we're just trying to assume that it's taking this binary form when really it might not? It might take some kind of triadic form or something much more complex. And then what about words in the middle? What about things like gender-neutral words? This is another thing that I've been really curious about, is like, what happens to those? Do they just go like randomly on either side of this binary opposition, or are they actually in the middle? And also I found that some of these meanings are much more easy to extract than others, and so that's a whole other question. You know, that could be like, because of this binary oppositions thing, maybe they don't fit that form, or it could be something else. So, okay, a few takeaways. It's increasingly popular to do this method of extracting something like gender or race or morality from a word embedding in a language model among computer scientists and also among social scientists. And it's really exciting. We can kind of test what's already been talked about in the literature, like with qualitative literature on obesity and immorality, but then we can also extend it to figure out new things, such as this slender and thin difference. At the same time, there's a lot of unknowns, and I think we need to proceed with a lot of caution and use these as opportunities to kind of probe the model a little bit more. And probing these models can tell us a lot about our own meanings and our own culture. They can also tell us about the limits and some new ideas and directions in language modeling and word embedding models. And then finally, I think that it can go back to that idea of machine learning bias and help us understand, like, when Google Translate's making those decisions, it's not just about removing the bias, but I think it's an opportunity to think a little bit more carefully and think about, you know, just because we notice gender is something that's translated, what else is being translated? What other kind of meanings are being propagated through all these different things, such as Google Translate or search recommendations, all these areas where we have language models that are influencing what we see. Right. Just thank you, and then a bunch of questions. I would love to hear anything. So.
Any question?
Is it possible to extract a dimension without an explicit binary? I mean, what if you just found like I'm looking at density of word vectors, for instance. You found like a bunch of words that were closely connected. Could you just combine them in the dictionary and then say that's its own dimension? Or do you need to, is it important to have the contrast?
It just means different things with a contrast. So if you just took a bunch of words and extracted them, you'd get it like a concept, right? That's one thing, but it's not going to point anywhere. You're going to be able to say, like, for example, if we just took the word, like a bunch of words about femininity and we projected it on, we could see how feminine a word is, but we're not going to get this sense of how feminine versus masculine it is, right? And a lot of femininity includes things, like femininity includes things about masculinity, about being human, and all these things that are not just femininity itself. So I think it's like, yeah, we could do that. It's just telling you a different thing.
Is there a way to induce the binary, or is that like an a priori?
At least the way that I've seen it, it's a priori. As far as inducing it, I mean, it's there. We're just finding this dimension. We're not making it. It's already there in this big space. So there's all kinds of potential oppositions or higher order complex structures in there that we just don't even know about, for sure.
Yeah. So, okay, this is fascinating. But you are in some ways assuming it's there when you track things that are significant, things that are feminine, the other way around, or things that are immoral versus things that are moral. You're assuming a binary exists because we seem to know a lot about it from research. But that's why I think it's hard to think about trimodal or multimodal concepts, right?
Yeah.
Cultural dimensions, right? So all culture is pattern meanings, right? That is talking about your system and values. And so it's a question of, this is for the non-sociologists. So it's just good to translate, right? And so you can think about patterns that aren't involved in a binary, but it's just a natural tendency because we are bilaterally symmetrical.
Yeah. And I think one argument would be that, like,
our bodies ourselves.
It's true, yeah. And I think one argument could be, and something I've kind of been thinking about is, like, it's not just that it's binary, but you can take binary things and construct larger things, just like we do when we code in a bunch of variables or categorical variables. We're putting them in as a bunch of dummy variables, right? And so you can have something larger like race, which is not binary, but you could say maybe it's comprised of a bunch of binary things. So, yeah. Oh, yeah.
I think it's really interesting from the perspective of some of the linguistic research that started in the in the 80s and still continues to this day in terms of thinking of word meaning in terms of frames, cultural frames, but also any kind of frame you want. A lot of contrasts were observed in particular areas of the lexicon, like, if you think about the difference between ground versus land, like if I say an animal lives most of its life on the ground versus on land, in one case I'm contrasting it with flying, and in the other case versus like living over the water or something. Or what is a pedestrian? A pedestrian is a person walking on the street, but if I say hit a pedestrian and it turns out later that I elbowed some guy while I was walking, then that's a little misleading because it's from the perspective of drivers. But then you ask like, okay, is this just a one-off observation that for this word, for this little group of words, the dimension of is the speaker a driver or not is relevant? Or is it actually something that pervades the lexicon? These things are actually really hard to discover. Like, how many other words care about air versus water? It's like, I don't know.
Yeah.
And I just wonder if there's a method that can be extracted from this for linguistic research. Like, what are actually the dimensions that a particular lexicon of the language cares about?
Mm-hmm. And we could do that. You could do something like some kind of dimensionality reduction and then see like what are the main dimensions. Oftentimes you just get gibberish is the problem, but that would be something kind of cool to do, yeah. Are we out of time? Okay, thank you.
Thank you very much.